Okay. Next one is the Verilog and system Verilog. Verilog is another hardware description language, and the Verilog is derived from the C language. Most of the features of Verilog languages are same as that of the VHDL languages, but some set of entities connections are different. It can also supports the concurrency. Concurrency means parallel operation. Parallel ports can be simulated at the same time. Here also we are using the bit vectors and the time unit concepts. Time notions are also available in the Verilog system. It's less flexible compared to the VHDL language. And both are almost same language, and VHDL is most popularly used in Europe and Verilog is used in the USA. VHDL is adopted the concept of ADA language, and Verilog we are using the C language concept. Okay, this is the Verilog code. In the like C language, like main program, in the Verilog code we can write module and the entity name. Module and the entity name. This is almost similar that of the C function. If you want to add two numbers and store the answer in the variable, means how can you do that? Read the two numbers and calculate the values and store the number in the another variable. So same thing like the function, like a function call, you should write. Okay, similar that of the function call. To write this as A, B, C function. So it indicates A and B. First two are the input, and the next one is the output. So module is important here. Like entity in the BHDL language, module is important. You should begin with module and end with module. And next is the entity name, module name. Give the name. Module means it's just a function call. Give the function name. Here my function name is NAND1, and three variables are there: A, B, C. A and B are the input and C is the output. I should specify that also. A and B are the input. Input is A comma B and the output is C. Then write the function. What we are going to do? NAND operation. NAND operation of here, when you see over here, during the function call, you should write the parameters in the order manner. That is, first two parameters here. First represents the inputs and the remaining represents the output. But when you are performing the operation, this is the binary operation of A and B. So you should indicate like this one, A and B. This is the binary operation of A and B, and that should be stored in C. Same thing, I can write it for the half adder also. Here my name is half adder 1, A, B, sum and carry. Input is A and B and output is sum and carry. And first one is the exclusive. First I am doing the exclusive operation. No, exclusive operation of A and B, and we already saw this truth table. A and B exclusive or operation is carried out, and that is stored in the sum. That's the meaning of this one. Similarly, next one is the carry. To find the carry, what you are going to do? Check the AND operation of A and B. The function or the operation, what you are doing is available outside this one. And here, this is the input and output variables. A and B AND operation is calculated, and that is stored in AND. So finally, end the module. Same thing can be tested and executed in the online compilers. So Verilog compilers are available. One of the compiler is online Verilog compiler. We can get it from JDoodle. JDoodle is example for the online Verilog compiler. I will start that. It's just you go and check the online Verilog compilers. You will find this compiler or JDoodle. JDoodle. Go to JDoodle. You can execute your own programs, harder description languages here. This is the JDoodle. Okay, go and let's code. It will ask you to search the compiler. Here, all the codes are there, all the different programming languages code, front-end frameworks, back-end frameworks, everything is MongoDB, everything is available in the JDoodle compiler. You can check anything, MySQL, everything you can execute here. I am looking for the Verilog compiler. You can get the Verilog compiler, start coding. Okay, this is the compiler. For everything, it's like a C language. You should begin everything with module. If you want to print high, then also you should begin the code with module. Here the name of the module is JDoodle. Initial begin. Here I am going to display welcome to Doodle. This is my program. Can do this also if I execute my code. Welcome to Doodle. It will be executed, and here you can see the execution time of this code also. Same manner when you design for this half adder or full adder other circuit, you can find the execution time. Your task of the code can be identified by this one. Here I'm going to execute my NAND gate also. If you want to check your logic, I have written the functionality for the NAND gate. This is for NAND gate. If we execute the code, okay, compiled and executed. So the execution is successful. So this is the small code that will simulate the function of the NAND gate. Like that, I can check all the functionalities, and based on that, I will simulate this code. With the editors, I can simulate this code for the hardwares. This is for NAND gates. Same manner, we have written the code for the half adder also. Here, this is just a code. Time permits, then I'll explain how this is connected to the hardware and how the signals are generated for the hardware. And this is the code for this half adder. So here you can write the code and check whether your code is correct or not. After that, we can generate the simulated circuitry. How to simulate the same code inside your program and inside your logic gates, and check that we will see in the next class.